NEC 230.2 Bone states that services shall have sufficient capacity to carry the maximum load under normal operating conditions. NEC 230.4 mentions services shall be sized to carry the total connected load plus the maximum demand of any single appliance. In a proposed arrangement where two condo units are combined, each with its own separately metered service, for example, 150 amps or 175 amps each, the combined service capacity would be the sum of the two, either 300 amps or 350 amps. The crucial question is whether the combined electrical load of the now unified condo unit exceeds the capacity of either of the original individual services. The code mandates that the service capacity be adequate for normal operating conditions, and the exception in NEC 230.4e addresses accommodating the maximum demand of a single appliance. However, the specific nature of the load and any appliances that might draw a load exceeding either individual service capacity has to be evaluated. The authority having jurisdiction, also known as the AHJ, plays a key role in determining compliance. They might require a detailed load calculation to assess whether the combined load surpasses the capacity of either service. The AHJ may also consider factors such as potential future load increases or the installation and use of heavy-duty appliances. The recommended approach involves several steps. Firstly, calculate the combined load of both units meticulously. Compare this calculated combined load to the capacity of each individual service. Secondly, consult with the AHJ to thoroughly discuss the proposed arrangement and obtain their explicit approval. Thirdly, if necessary, upgrade the service capacity or consider installing a completely new service to adequately meet the combined load requirements. Additionally, the local building code is also relevant. These codes might have specific requirements pertaining to combining units and any alterations to electrical systems. Consultation with the local building department is essential for specific guidance on these matters. Proper smoke and carbon monoxide detection should be installed throughout the combined condo unit, according to the manufacturer's specifications and local regulations. A detailed load calculation involves several steps. Firstly, determine the general lighting load. According to the NEC, dwelling units require a minimum general lighting load of 3 volt amps per square foot. Multiply the total square footage of the combined condo unit by 3 volt amps per square foot to determine the total general lighting load. Secondly, account for small appliance and laundry circuits. NEC 220.52 requires a minimum of 2 20 amp small appliance branch circuits and at least one 20 amp laundry circuit. Each 20 amp, 120 volt circuit is calculated at 1500 volt amps. Therefore, add 3000 volt amps for the small appliance circuits and 1500 volt amps for the laundry circuit to the total load. Thirdly, consider the appliance loads. Identify all fixed appliances such as ranges, ovens, cooktops, dishwashers, water heaters, clothes dryers, and air conditioners. Obtain the nameplate ratings for each appliance in volt amps or watts, noting that watts can be converted to volt amps by dividing by the voltage. For ranges, follow the demand factors specified in NEC Table 220.55. For example, a range rated at not over 12 kilowatts has a demand factor of 8 kilowatts or 8000 volt amps. For electric clothes dryers, use 5000 volt amps unless the nameplate rating is higher. For air conditioning and heat pump equipment, use the largest of the compressor's nameplate rated load current and the fan motor's nameplate rated load current, multiplied by the voltage. Fourthly, account for heating and air conditioning loads. If the condo unit has electric heating, calculate the heating load at 100% of the nameplate rating. For air conditioning, calculate the load at 100% of the equipment's nameplate rating. If both heating and air conditioning are present, only the larger of the two loads needs to be included in the total calculation. Fifthly, consider motor loads. For permanently connected motors, such as those for ventilation fans or pumps, use the motor's full load current rating from NEC Tables 430.248, 430.249, and 430.250. Multiply the current by the voltage to obtain the volt amp load. Sixthly, apply demand factors where applicable. The NEC allows for demand factors to be applied to certain loads, such as ranges and space heating, where it is unlikely that all appliances and equipment will operate at their maximum load simultaneously. Apply these demand factors according to NEC Article 220. Seventhly, calculate the total connected load. Sum all the individual loads calculated in the previous steps to determine the total connected load in volt-amps. Eighthly, determine the maximum demand. Apply any applicable demand factors to the total connected load to estimate the maximum demand. This represents the maximum amount of power the combined Condo unit is likely to draw at any given time. Ninthly, compare the maximum demand to the service capacity. Compare the calculated maximum demand to the capacity of each of the existing services, typically expressed in amps at a specific voltage, such as 120 volts or 240 volts. The service capacity is determined by the size of the service entrance conductors and the rating of the main overcurrent protective device, such as a circuit breaker or fuse. Tenthly, evaluate the results. If the maximum demand exceeds the capacity of either of the existing services, an upgrade will be necessary. This may involve increasing the size of the service entrance conductors, upgrading the main overcurrent protective device, and potentially replacing the electrical panel. If the maximum demand is less than the capacity of the existing services may be adequate, but it is still recommended to consult with the AHJ to confirm compliance and address any potential future load increases. The local building department should be consulted for requirements related to combining units and altering electrical systems. Firstly, obtain the necessary permits. Before commencing any work, obtain the necessary permits from the local building department. This ensures that the project complies with all applicable codes and regulations and that inspections will be performed to verify the work. Secondly, hire a qualified electrician. Engage a licensed and experienced electrician to perform the electrical work. A qualified electrician will be familiar with local codes and regulations and will ensure that the work is performed safely and correctly. Thirdly, perform a thorough inspection. Before starting any demolition or construction, perform a thorough inspection of the existing electrical systems in both Condo units. Identify any potential hazards, such as damaged wiring, overloaded circuits, or code violations. Fourthly, disconnect the power. Before commencing any electrical work, disconnect the power to the affected circuits at the main electrical panel. This helps prevent electrical shock and ensures that the work can be performed safely. Fifthly, remove the demising wall. Carefully remove the demising wall between the two Condo units, taking care not to damage any electrical wiring or components. If any wiring or components need to be relocated, do so in accordance with the NEC and local codes. Sixthly, combine the electrical circuits. Combine the electrical circuits from the two Condo units as needed to create a unified electrical system. Ensure that all circuits are properly grounded and that the combined load does not exceed the capacity of the existing services. Seventhly, install new wiring and devices. Install any new wiring, outlets, switches, and lighting fixtures as needed to meet the needs of the combined Condo unit. Ensure that all wiring and devices are installed in accordance with the NEC and local codes. Eighthly, upgrade the electrical panel if necessary. If the existing electrical panel is not large enough to accommodate the combined load of the two Condo units, upgrade the panel to a larger size. This may involve replacing the panel with a new one or adding a sub-panel. Ninthly, test the electrical system. After completing the electrical work, thoroughly test the entire electrical system to ensure that it is functioning properly. Check for proper voltage, continuity, and grounding. Tenthly, obtain a final inspection. Schedule a final inspection with the local building department to verify that the electrical work has been performed in accordance with all applicable codes and regulations. Address any deficiencies identified during the inspection promptly. Proper smoke and carbon monoxide detection is crucial for the safety of the occupants of the combined Condo unit. Firstly, install smoke detectors. Install smoke detectors in each bedroom outside each sleeping area and on each level of the combined condo unit. Ensure that the smoke detectors are interconnected so that if one detector sounds, all detectors will sound. Secondly, install carbon monoxide detectors. Install carbon monoxide detectors on each level of the combined condo unit and outside each sleeping area. Ensure that the carbon monoxide detectors are installed in accordance with the manufacturer's instructions and local codes. Thirdly, test the detectors regularly. Test the smoke and carbon monoxide detectors regularly, typically once a month, to ensure that they are functioning properly. Replace the batteries in the detectors at least once a year or as recommended by the manufacturer. Fourthly, maintain the detectors. Keep the smoke and carbon monoxide detectors clean and free of dust and debris. Replace the detectors every 10 years or as recommended by the manufacturer. Fifthly, educate occupants. Educate the occupants of the combined condo unit about the importance of smoke and carbon monoxide detection and what to do in the event of an alarm. The AHA role extends beyond initial approval and inspection. Firstly, interpretation of codes. The AHA is responsible for interpreting and enforcing the electrical codes within their jurisdiction. They provide guidance on how the codes apply to specific situations and projects. Secondly, plan review. The AHA reviews electrical plans and specifications to ensure that they comply with applicable codes and regulations. They identify potential code violations and require corrections before work can commence. Thirdly, inspections. The AHA conducts inspections of electrical work to verify that it has been performed in accordance with approved plans and specifications and that it complies with applicable codes and regulations. They identify any deficiencies and require corrections to ensure safety and compliance. Fourthly, enforcement. The AHA has the authority to enforce the electrical codes and regulations. They can issue warnings, fines, and stop work orders to ensure compliance. Fifthly, education and outreach. The AHA provides education and outreach to electricians, contractors, and the public on electrical safety and code compliance. They conduct training sessions, workshops, and seminars to promote awareness and understanding of electrical codes. The NEC, or National Electrical Code, is a comprehensive set of standards and guidelines for electrical installations in the United States. Firstly, purpose. The NEC is intended to safeguard persons and property from hazards arising from the use of electricity. It establishes minimum requirements for electrical wiring, equipment, and systems. Secondly, scope. The NEC covers a wide range of electrical installations, including residential, commercial, and industrial buildings, as well as outdoor installations and special occupancies. Thirdly, organization. The NEC is organized into chapters, articles, and sections, covering various aspects of electrical installations. It includes requirements for wiring methods, overcurrent protection, grounding equipment, and special conditions. Fourthly, adoption and enforcement. The NEC is adopted and enforced by state and local jurisdictions. It is updated every 3 years to reflect changes in technology and industry practices. Fifthly, interpretations and amendments. The AHA has the authority to interpret and amend the NEC to address local conditions and specific situations. They may issue local amendments or interpretations to clarify or modify the requirements of the NEC. In summary, when combining two condo units and considering the electrical service, it's essential to prioritize safety and code compliance. Starting with a comprehensive load calculation is paramount, ensuring that the existing service capacity can handle the combined load. Engaging with the AHA early in the process is crucial, as their approval is necessary for any modifications. Adhering to the NEC and local building codes is non-negotiable, and proper smoke and carbon monoxide detection systems must be in place. By following these steps, one can ensure that the electrical system in the combined condo unit is safe, reliable, and compliant with all applicable regulations. Remember, electrical work should always be performed by a qualified and licensed electrician.